All right. Lastly, we're going to incorporate mid-infrared data. And you learned how to find this data on the internet, how to grab it before. So I'm not going to go over that again, except to say you have two options. You have Spitzer and you have Weiss. And the Spitzer data is better. If at all possible, use the Spitzer data, Spitzer 8, Spitzer 24. If not, Weiss 12, Weiss 22. But the Spitzer data has better angular resolution. It's crisper, and its angular resolution more naturally matches that of your optical images. So go searching for that first. Now, let's start with the warm dust, Spitzer 8 or Weiss 12. There are kind of two scenarios. There's the scenario where it does not line up with the H alpha. They're coming from different parts of the galaxy. And there's the scenario where they do line up and they're essentially coming from the same part of the galaxy. This usually depends on how big your galaxy is in your image. Here I'm doing the Sculptor galaxy. It's nearby. It's huge. I'm going to see more detail because of that. And in this case, I'll be able to see separation between the H alpha, the hot gas, and the Spitzer 8, the warm dust. So let's do that case first. I'm going to turn on the warm dust. There it is. I am going to switch to the warm layer, going to put it in manual mode, unlink it. Okay. It's already in mid-tone. I'm going to hit the default. And I'm going to set the background and mid-tone levels. Interesting to see here, our Spitzer data did not cover our entire frame, so we'll be missing it in certain places. But if we do this right, it won't look so bad. Let's go to the Spitzer 8 layer, set the background level, 10, 20, 30, 40, back it down to 30. Okay. And darken the background. Go back to the group here. We're going to set the mid-tone level. I have this in the screen mode. Change it to 99.999. Okay, I'm going to start taking out nines until I'm happy with what I see. Oh, let's put that last 9 back in. Okay, that looks pretty good. Might want to dim it just a little bit more. Let's see. Try to achieve some parity between the warm dust, which appears to be closer in, and the hot gas, which we're seeing a little bit farther out. Now here's another little effect and trick. Here in the center, you see it's been blown out, saturated. Makes the picture kind of ugly. If you want to get rid of that, you need to increase the saturation level beyond 100%. And how do you do that? It won't let you go beyond 100%. What you could do is you could take it out of pixel mode. That replaces those percentiles with the actual pixel values. And then the saturation level, you can increase it. Like I'll add 1,000 points to it there. See how that made that better in the middle? And when you do that, you're probably going to have to adjust the mid-tone level to compensate. Yeah, something like that. Maybe I'll go a little bit higher. Let's see. Yeah, something like that. Zoom out, see if we like it. Yeah, I like it. Okay. So this is, again, the example where they don't occupy the same places in the galaxy. So we can highlight both and talk about both physically. Now, let's do the case where it's duplicative. Basically, the warm dust and the hot gas are in the same place. Let's come up to Messier 83 here. Now turn on the H alpha layer. I've already set all the levels. There it is. You can see those star forming regions. They look nice. Now I'm going to turn that off and I'm going to turn on Spitzer 8, where I've colored it the bomber color. And it looks about the same. Now remember back when you did your star forming region, it had warm dust, it had hot gas, and they were well separated. We used their separation to help figure out what's going on, to do stronger sphere calculations, etc. Well, each one of these dots is a star-forming region. We've zoomed so far out that the hot gas and the warm dust, it's all kind of mixed together. And so you can use one or the other. If you collected H alpha data and it's not very good, kind of ratty, there may only be so much you can do with it. Go and check your Spitzer data. It may be a good substitute. And remember, H alpha is very expensive to acquire. But Spitzer 8, it's cheap, it's free, it's online. So instead of going back and getting more H alpha, if it's not working out for you, instead, grab the Spitzer 8 and see if that will work instead. Okay, one more example. Let's go to this, Fornax A, and another galaxy. They may be interacting with each other. Fornax A is a cannibalistic galaxy, a cannibalistic lenticular. We see some dust here, probably from the last spiral at 8. And let's see if that dust is warm or cold. In this case, I got both Spitzer 8 and Spitzer 24. Let's start by turning on the Spitzer 8 layer. I've already adjusted the levels, so indeed that is warm gas. See how it turned orange? And we got some warm gas in this galaxy over here with a very interesting structure. And also some of these background points, some didn't change, which means those are foreground stars. But these background ones, those are galaxies. That's the warm gas in those galaxies. This really brings out the galaxies. But it could be more interesting if we also add the cold dust and give it a different color so we have some color definition. So I'll turn on the Spitzer 24. Here I'm using the cool color map. I've already set the levels. And so you can see, particularly over here, we have some nice color gradation between the warm dust and the cool dust. The warm dust is about 300 Kelvin, the cool dust about 100. In the background galaxies, we have a distribution of colors now. From orange, those are warmer distributions, to pink, which is some warm dust and some cold dust, to kind of the deeper purple, which is colder distributions of dust in those galaxies. And that's indicative of the star formation in these background galaxies. More star formation, warmer dust. Okay, that's it for this video.